We are finished with our reactions and ready to compute our internal forces. We take a section S1, S1 as shown, which divides the truss into a left part, left to section S1, S1, and another part right to it. We are convenient with computations concerning the left part. So we extracted here, and we recall that the only internal forces that appear are the forces of the members that had the cut. Any other member that didn't have the cut, S1, S1, its internal force doesn't appear. Considering FDC makes angle 45 with the horizontal, and therefore it is analyzed into two components, the horizontal and the vertical components. Sigma moment about C equals 0. This cancels the forces passing by C, the force in GC and the force in DC, and we are left with the force in DE to be the only unknown here. So we have 17 rotating clockwise about C taken positive and multiplied by the arm 8, and 10 rotating counterclockwise about C having an opposite sign, a negative sign, and multiplied by the same arm D, and therefore both forces may be computed in one shot. 17 minus 10 by 8. And the force FDE multiplied by the arm, which is a perpendicular from C to DE. This gives DE equals 14 tons tension force and is plotted on our diagram. We note that the force in DE is a key force which can be very significant in computing other forces, and therefore we were convenient to start with it. Sigma forces in the y direction equals 0. We just have our section outside and we sum up all the forces in the y direction respecting the signs. This gives FDC equals 9.09 and is plotted on our diagram. Sigma forces in the x direction equals 0. We consider all forces in the x direction. FDC is previously computed here, and we are left only with GC unknown, which gives FGC equals minus 7 tons compression and is plotted on our diagram. Now we have those forces previously plotted. We take another section S2, S2, and we extract the left part of section S2, S2 for our computations. FDA is analyzed into a horizontal and a vertical component. Sigma moments about D equals 0 gives 17 minus 10 tons multiplied by the arm 4, and we explained previously that those two forces can be summed up together if they have the same arm. And the force in FG multiplied by the arm, the vertical arm, 4 meters equals 0. This gives the force in FG equals minus 7 tons compression and is plotted on our diagram. And really it could have been faster and easier to consider joint G and have sigma forces in the x direction equals 0 just to compute the internal force in FG. Sigma moments about F equals 0. So the forces in FG and FD do not appear. Also, the external 10 tons and 17 tons do not appear. All these forces pass by the joint F. And we are left with the horizontal component F in dA cosine 45 multiplied by 8 equals 0, which gives that FdA equals 0 and plotted on our diagram. We consider forces in the y direction equal 0. And in this case, we need to analyze the force in FD into its horizontal and vertical components. So we have the equation 17 minus 10, those are the external forces, plus FdA sine 45, which was previously computed to be 0, of course, and the component of FD heading downwards in the y direction and having a negative sign. This is the only unknown in the equation. So we have the force in FD equals 9.9 tons and is plotted on our diagram here. We proceed with a third cut, S3, S3 as shown on the diagram. And we consider the internal forces of the members that had a cut. We extract the right part to have our computations. And we analyze the force in AC into its vertical and horizontal components. We take the moments about E to be equal to 0. And therefore, the force in HC will be the only unknown. The forces considered are 13 tons minus 10 tons, both multiplied by the horizontal arm, 4 meters, and therefore can be computed in one shot. We considered here that the rotation in the counterclockwise to be positive, and therefore the 4 tons blue here multiplied by the vertical arm is rotating counterclockwise and have a positive sign. The force XB also rotates counterclockwise and has a positive sign. And the force in HC rotates in the positive sign also about E. This gives the force in HC equals minus 11 tons compression and is plotted on our diagram here. Considering the forces in the y direction to be equal to 0, we consider 13 minus ton plus the vertical component of EC. And we have force in EC equals minus 4.24 tons compression and is plotted on our diagram. Joint F, to consider the joints, we simply have this plot which indicates that all internal forces are considered to be tension forces, and we extract our joint F with all the external and internal forces connected to it, and we analyze the force in FD into the two components. Considering sigma forces in the y direction equals 0, we already have the force in FD, and we are left with the only unknown force in FA. We compensate or substitute for the force in FD by its value and sign, which gives FA equals minus 17 tons compression and is plotted on our diagram here. Considering the joint H, we extract it here. And we consider the forces in the x direction. We already computed the force in CH. We substitute for it, which gives the force in HI equals minus 11 tons compression and is plotted here on our diagram. We consider the forces in the y direction, which gives that the force in HE equals 0 and is plotted on our diagram. Joint G, we extract it here. The forces, the horizontal forces, are previously computed and we are left with the only unknown at G, F, G, D, which can be computed from the y direction. And the value is 0 and is plotted on our diagram. Now we consider joint B. We extract it here, having the external forces, reactions YB and XB, and the internal forces FBI and FBE. Now, let's think it over. If we consider sigma forces in the y direction, we will have two unknowns, BI and the component of BE. So, it is better to start with the sigma forces in the x direction, as this will give one unknown, which is BE, equal to 5.66, and we plot it on our diagram. We consider now the forces in the y direction, as we have already computed BE and we are left only with BI, one unknown in one equation. Substitute for FBE by 5.66 and we have the force in BI equals minus 17 tons compression, and we plot it on our diagram. Finally, we have joint I. We extracted here with the external blue forces and the internal red forces. We already have minus 11 tons and minus 17 tons for IH and IB respectively. So the only unknown here is IE. We analyze it into the horizontal and vertical components, and we take sigma forces in the y direction equals 0. Of course, if we take in the x direction equals 0, we will also have this only unknown. So it really makes no difference. Here we have our computations. IB is already known, minus 17 tons, which we can substitute it here, and this gives FIE equals plus 9.90 tons tension and is plotted here on our diagram. We can have a check. Sigma forces in the x direction for the same joint I equals 0, which means that you can have any check at any joint, of course. If your equation is fulfilled, then you can know that all previous computations were correct. Thanks for watching. This concludes with our example.